Hello everyone, welcome back to our geometry class. In the previous lesson, we discussed how to use coordinate geometry to prove parallelograms. And in those lessons, we actually use two methods to prove the parallelogram to prove a quadrilateral as a parallelogram. So just want to quickly just recap what we mentioned before. The two methods, the first two methods we use, we can prove both pairs of the sides parallel, and we can also prove both pair of the opposite sides are congruent. So today we actually, I want to discuss the last method. So in this document, the last method says show diagonals bisect each other. So we are going to discuss what kind of formula can we use to prove the diagonals bisect each other. So if you just look at the diagonals bisect each other, it seems that the distance we actually prove the sides are congruent, and the slope formula we use to prove parallel. It seems that none of the formula can actually lead to this conversation. And also, it seems that in coordinate, how do we actually show diagonals bisect each other? What does that mean when we say bisect each other? So one thing we need to keep in mind is when we say bisect each other, you can think about, the word is actually we cut each other into two halves, right? So for example, for AM here, AM is going to be equal to MC, it cut in half. DM is going to equal to MB, it's also cut in half. So they actually cut each other into two equivalent parts that actually bisect each other. Then if for example, I have two diagonals here, just random two diagonals here, then how do we even show on the coordinate plane they bisect each other? How do we even show this piece is congruent to each piece, this part is congruent to this part? Do I have to use this formula to prove these two pieces are same? Actually, no, we don't need to. So to prove this one, we can actually use a new formula, which is called midpoint formula. So midpoint formula, what is midpoint formula? Midpoint is, let me erase this part to make it more clear. For example, I do have a random two segments here. So midpoint formula, midpoint, very straightforward. I give you a segment. The points stay in the middle of the segments we call midpoint. So midpoint formula, the reason we use here because if I can prove the two segments have exactly same midpoint, they share the same midpoint, then that will telling us they cut each other into two halves. So that's actually, we are going to very straightforward use the midpoint formula to tell us, to determine are both segments have the same midpoint? Yes, they do. That means they bisect each other. And let's look closely about what is midpoint formula. First of all, it is still a point. Midpoint is still a point. So whenever we talk about the point, it have x coordinates, we have y coordinates. And the midpoint formula is, if I give you a random 2 points, remember this is a 2 points we have here. If I want to locate the midpoint between these two endpoints, we can find the sum of x, the sum of y, and divide by 2. And that will be the coordinates of this midpoint. So I can just easily to read the endpoints coordinates and then plug into the formula, find the midpoint compared to the other one to say, hey, do I have the same midpoint? Yes, I do. Okay, they bisect each other. So we are going to use this formula to complete the proof today. So let's do some like a real example to improve our understanding for this situation. Okay, so now I have a quadrilateral ABCD is drawn on the graph. We need to prove is this a parallelogram or not. And the method we decide is we are going to show diagonals bisect each other. And we mentioned in order to do that, we are going to use midpoint. And remember, to use midpoint formula, we need to compare our diagonals have the same midpoint, so we need to find two midpoints to compare if we have the same midpoints, right? Two midpoints between two diagonals. Remember, we are looking for diagonals. So diagonals, as we mentioned, is connecting two opposite angles from A to C, from B to B to D. Even we do not have this on the graph, we can still focus on that. Without graphing, we can still focus on where is midpoint between AC, where is midpoint between BD. So let's do the proof. First midpoint of, remember again, you're looking for diagonals. So you're looking for midpoint of AC. As we mentioned, the midpoint formula is we find the sum of x, we find the sum of y divided by 2 for both. So that's why for midpoint of AC, this is my x1, x2. So 2 plus 6 divided by 2. Again, focus on the x and then focus on y. -1 plus 5 divided by 2. Remember, this is coordinate, so this is a parenthesis. 2 plus 8 is 8. 2 plus 6 is 8. 8 divided by 2, 4. Then this is -5. -1 plus 5, 4 divided by 2, 2. So midpoint of AC is 4, 2. Is 1, 2, 3, 4. 4, 2 is here. So this is a midpoint for AC. Now we are going to continue working on midpoint of BD. Remember, again, you are looking at, even I don't have this graph, this line, I can still see, I'm going to imagine this is diagonal BD. So I'm going to use that one. Again, find the sum of x, which is 1 and 7, divided by 2. This time it is 3 and 1 for y. Do not forget the parentheses, because this is a point. 1 plus 8, 1 plus 7, 8, divided by 2, 4, and 2 divided by 2, 4. 2. So now I have exactly same midpoint. So what does that mean? That means AC and BD bisect each other. Remember, we always need to explain because they have the same midpoint. But do not forget, that's your explanation for your calculation. Finally, we are going to write down the conclusion, right? Conclusion is, so we do know ABCD is a parallelogram. Sorry for my handwriting. Because what? Because ACBD in this graph is actually diagonal. So because diagonals bisect each other. Okay, sorry for my handwriting, but the idea is clear. So first, we decide what method we choose. We want to prove, we want to use diagonals. Even we do not see the graph, but diagonal is always, from the diagonal 2 points to endpoints. So we use a midpoint formula. We plug into the value, compare the midpoint, and they actually have the same midpoint, which means these two diagonals bisect each other because they have the same midpoint. And finally, we can tell ABCD is true. So the final question is, the answer is yes, it is a parallelogram because diagonals bisect each other. If you want to prove these two sentences as the same conclusion, combine them together, you can. You can tell these diagonals bisect each other because the calculation shows they do have a same midpoint. So basically, we just use these sentences to indicate what calculation means and what method did we use to prove it is a parallelogram. Okay, so this is how do we use a midpoint formula to prove this. And the new idea is this is a midpoint formula. So we actually, in coordinate geometry, we use distance, we use slope, we actually use midpoint formula. And midpoint formula, the special use for this one is to prove the bisecting part. Okay, I hope this video is helpful for you to now you have a better understanding for the whole picture using coordinate geometry to prove the parallelograms. Definitely, the more practice you do, the better you will be. Thank you so much for watching this video. Study this topic with me. Take care, everyone. See you soon.